Well, hello again. Here is Robert de Lauw from Holland, and I'm continuing my lectures about the things I know about. So I've called everything what I learned and what I know, what I see, what I understand, and what I find out step by step. And this is what you see is related to the special or the so-called relativity from Einstein and his gedachte-experimenten of mind experiments. I will now go forward for the camera, so sorry for my inconvenience. Hello. I have to continue my story for several reasons, because I posted many lectures on YouTube, on the internet, about the speed of light and the gravity and all those kind of things. I also placed some Dutch lectures about waves, water, how they behave in ships and planes and whatsoever. But what you see here is many times an experiment used on a train or on a spaceship, that there is an astronaut or an astronaut in an elevator or in a spacecraft. And well, I see it. I see it otherwise. I have my own mind experiments. For example, we take a happy person with a light bulb on his head, and this light blinks. Some frequency and the frequency, wavelength, and the amplitude of his wavelength. Nobody talk about it. In one of my, especially my Dutch lectures, I asked that for scientists to search for, and maybe they already know when they understand what I'm talking about. First, he gives one wavelength and an amplitude. A wavelength always has this length, and he got this plus, and he got this minus amplitude. So it's going up and going down, and this phase is one frequency. Lambda is the length of the wave. So when a light bulb creates a flash or a constant light beam, but for instance just a light beam, doesn't matter, and he sends out a light signal 360 degrees everywhere, but I think, for example, he is standing still, he is grounded, and his light bulb sends light to the left and to the right. This is time frame 1, time frame 2, at the same time frame 2 by the other side, and everywhere around. But as soon this light equipment makes one frequency, and he does that in our ether, in our space, in our universe, platform, quantum, foam, quantum fluctuation. What happens is, you can say, when there's nothing to change, then there's no resistance, there is no interaction, there is just this wave. It's when it's created, it's going on and on and on. That means that the universe has to have its own energy to have this speed of light. The speed of light, called c, that has a certain kind of speed. All about something like that. It's quite fast, very fast. So I cannot give with a baseball bat or with a punch or with a cannon. I cannot create a light wave in the universe, in the ether, in space that make it always about 300 meters per second. So that means that our universe has this energy. And in my former lecture about the universe, light, speed of light, gravity, I explained where it is all happening in. But this speed of light is coming from the ether, is coming from the base where our universe exists in, what we see. We exist in the universe, and there is this intrinsic, enormous amount of energy inside it, because you cannot send a wave through nothing. You cannot send a wave through nothing, and it would only be an arrow or a stick or a ball or a photon ball. It cannot be. So the speed when you create with your light bulb, you create some wave particle movement from your equipment. This energy creates in this bulb, in this light bulb. Then it emits a light frequency with a steady frequency. And it's constant. In this line, you think. But when it's constant, then it will always be traveling on and on and on and on and on and on. But this energy over here, the power, depends on the radius from where it's sent out. So when you send it out, you will if you send on this level the power, you send out some light. Eventually it will go all the way enormously to some level about where it's all back in interaction where it came from. The interaction of our universe, of our platform, where this exists in, where this energy already is. And there we take, and from this we take our matter. That's also the transition formula. E is squares mass times the speed of light to the powers of 2. So in this already energy field, we create, or in this balanced energy field, we create a distortion. And the distortion, that is what we do with our light bulb. And from here, and this is the radius from where we send it. And we could also draw a line over there, so it's also in this direction, in this direction, in this direction. And from here, from this point, we can also make some other draw line from this and this. So wherever we are, the energy dissolves. So light always dissolves. But there is also a starting position from the frequency that we send. If you imagine, this is a graph of the highest possible wavelength. It's the alpha, beta and other particles. From this frequency we come to Röntgen, UV, infrared. So let's say the visible light, because they draw a beautiful long line always. You always see this frequency line, and then suddenly they go on with this. That means that they think about that this A plus, A minus, amplitude plus minus is steady. It's a little bit drawn always, but just like this. So you start with a high frequency, and in the visible light is so, and in the radio light it's so. So it moves from very high frequency to low. Well, this is not quite the case, because then there is a limitation about this energy that you give to this energy field of our universe, distortion in our energy field in our universe. So, and that's 300,000 meters per second. So this is always what we see. It's always, of course, it's a small boundary, but, and they say about this range, this is on blue, red and green or something, and about purple, cyan, all the kind of stuff. This is infrared, this is radio, and from long radio waves, and this is UV light, and you got Röntgen, and then you get the smallest, the highest frequency, it's alpha, beta, gamma. That's for the real scientists. They know exactly all the symbols. I know. They're in the book, the analyst. But what they do is actually, oh, keep it over here. I can handle everything at the same time. Don't be afraid. But actually, that means it's on this real, from this high frequency to a low frequency to a long frequency. You can see that this is our visible light. Visible light, and in this part it's ultraviolet, and in this part we got infrared, warmth, and over here we got microwave and radio waves to that side. So in this frequency, from this to this to there, so in the movement from here to there is our visible light. The bigger ones, the faster ones, are ultraviolet, Röntgen, and the particles, the particle waves. What's up there deep in the smallest matter of our elements. The elements created from our universe in this beautiful formula, and I didn't know that. E equals mass. This one over here. But it's actually a high frequency. This means an enormous amplitude with a small wavelength. That's what's actually going on. And in this visible part, we see everything. And it's not so quite so this in the angle of momentum, it's not so strange when you look at the visible part is somewhere over here. That means, I must say, maybe it's about 45 degrees. And it means that wavelengths, when they are wavelengths, they are a static dynamic distortion of our force field or from our universe, our place, our matter, everything what we have. But all the matter what comes is that this has another, say that, force in this picture of forces that going up and down and back and forth and left and right. There is an interaction with all these frequencies on particles or none, and the high frequencies go through, the high frequencies go through matter, and the low frequencies go otherwise through matter. But in between them, we got this beautiful part of visible light that doesn't go through it, only a bit, but there is some part that this is why we see everything. If we would live in our Röntgen spectrum, we only see some shades, many shades of grey. And when we would see some radio, we don't see anything. We only feel some warmth. So this is heat and this is an interaction. Do particles, so atoms live steady in between this part. In this frequency part, it interacts more and more and more to the basic physics where it's existing from and in. And in the outer region there is an influence by this wave, static dynamic wave that is created somewhere in an apparatus, and it goes through all matter, but it doesn't affect matter at all. That's why the radio is over here and it can heat you up, but that's in a microwave setting, and somewhere about here you must be sitting on the highest antenna or wave creator to heat yourself up, like in a microwave, so concentrated. So all light, what we know, mostly posted on a one level of amplitude. That means that everything is fast in a restricted border. This is not true. This is not, it really is. Frequencies says you are high, and then therefore you can also have the formula. This is the positive amplitude, negative amplitude together times the wavelength is constant, because it comes out the same interaction, distortion or influence in our universe. In our universe, our platform has to be this combination. So all this out here, so this is all an interaction through this dimensional, dimension, this medium, this universe, this lovely universe. But you see, for the normal light doesn't travel. Light is emitting a static dynamic distortion under a certain force created by a bulb and apparatus and equipment, And it doesn't matter if it's visible light or it is infrared or ultraviolet or microwave or radio wave or Röntgen wave. This is what it does. But as soon as it's emitted from one point and it's shines out or it radiates outside, so light always maybe from this, seen as this, maybe I can erase this a little. Oh, my mind association are really rattling, but it doesn't matter. Okay, we always fix it. So this light bulb P emits light, and it doesn't matter if it's this way, etc. It's in all directions. So it's X, Z, minus I, and X minus. And it's behaved by this formula. It's always power takes on. Power is immer Deutsch, alles durcheinander, ja, das kann ich auch nicht passieren. Aber from here, the light goes weaker and weaker. And when you, that's another story, but then you go by optics. But light gets a little denser when it's far away. But light isn't just a thing on its own. Light isn't just a thing what you throw in space or push out. Light is an interaction created in our universe, in our force field, in our ether, in our space, where it's all existing in. By these symptoms in that speed. So this speed is already in every single part in the universe, and it's diverse. This is not constant. This depends where it is, here or there, nearby mass or far away from masses. So there's also an influence when this should be a planet, also a P. There is over here a different kind of light speed and far, several, maybe a light year away, or 10 or 10,000 of 100 light years away. It's denser. This is always affected by matter, because it's also an interaction of matter, of light, particles and energy whatsoever. So what happens when you send out light with a certain kind of wavelength, wave height, the amplitude, this is constant from the moment that you send it out, then you don't send it out just from here, from scratch, from zero. No, you send it out, imagine, just in the middle of the visible light. It's over here. We send a signal in the middle of our visible light. We send out light. And then when and this is a constant movement, but when you further away from our star, from our sun, further away, there will be a little distortion from this. They call it this shifting. They call it wave redshift, and therefore they think that our universe is expanding but you must please watch my other lectures in this version about that. But on this time, on this moment, we send out a wave on this height. And when we do that, then it finally, over a long distance, it will disperse in another small changing wavelength, because the energy is dissolving, it's dispersed in just like a how can I say that over here? When you throw a stone in water, you see, and then it's getting longer. So this is from here to a wave height from here, but a wavelength from here to a wavelength from there. So this is 1, this is 2, and this is 1. Sorry. This is then 2, and then is this. This is 1. So somewhere on the way, when we look at this height, when it exchanges, this height on this point, here between this is constant alternating from plus and minus during the wavelength. So eventually, at a long distance, there will be a little bit shifting, because it's dimming out. The height is dimming out. When the energy goes with this formula, just like light, just like energy, just like the formula for gravity, light, magnetism, it slows down by this part of the formula. You get something and you divide it, and when you divide it in a circle, it is this, and it doesn't matter what direction it is, it's divided, and it will be with this formula that I showed before, a small formula. You start here, and then it ends somewhere at the end. In the end, when it's back in interaction with our universe, with our ether, you can come on this. You come on this side, and so there's also, then there's no distortion anymore from which light wave whatsoever. So in this, I would say it, in this, and I really get away with this. This is my distortion in my thoughts. Something different is going to happen when we travel. But this is light, this is our universe. This is an interaction between. Light doesn't exist just as in the grocery store, or a photon in the grocery store, or gravitational force. This gravitational force comes all the way by the existence of this and by the existence of that, and all this particle physics that's already well known. But this is not just existing just like that. You can't buy it, you can't buy gravitational force, you can't make it, create it, you cannot. Because it's existing in a particle world that's smaller than us, and there's another lecture about it, and there are a lot of books and scientists. So okay, that doesn't change anything on this kind of thing that I am trying to explain, telling about. But it comes. This is a person with a blinking idea. That could be me. And this is a steady place. And then we're gonna move. This person, this light bulb on his head, is moving with an enormous speed. That you say, well, it's not as fast. And I call this C momentum. Momentane speed of light somewhere in the universe. Nearby a black hole, or far away from a black hole, or nearby a huge sun, or a small sun, or average sun like us, of on Earth here, somewhere here nearby me. But if you move quite fast in relation to the speed of the momentum, constant speed of light, and then light doesn't travels, just like sound, it travels, but it's the interaction. And sound is it molecules that are interacting, they bumping and they vibrate on a certain frequency, and that's what they initiate. They are initiated by a force, by some pressure, by some explosion or some other reaction, and light is just a way down there in the dimension scale. And what happens next? That's if this light bulb emits the same wavelength and wave height, plus minus, is constant. This is one equipment and it doesn't do anything else. It just sends out an average light, halfway this. What happens next in this movement, what he does, he moves that way. So sideways, there is an interaction with a bow. There's a parabolic wave spur. But when we look straight in the direction of where the wave is sent to, this wave is sent with the same power strength, with its frequency together, constant. What happens when it goes very fast, he sends out the same power, but because this is constant, there must be another explanation what happens. So the frequency is getting higher, and it's not higher, but in this interaction, in this interaction in the universe, it gets a higher frequency because he pulls out, and in this interaction where he creates this frequency light signal, whatever it is, photon signal, he sends it out with a static dynamic pulse, and it has a higher frequency per second than it did originally over here. So this is a higher amplitude, higher frequency, but the wavelength is shorter. So the amplitude plus minus is bigger and the wavelength is shorter. That's the redshift part of it. And when it's going, when you leave it behind, you send your light behind from where you came from, there is a opposite fluctuation, and that means that this amplitude is getting lower because you haven't got power to emit. It doesn't send an emission signal just like that. You go and it will be divided in function of your speed. So the amplitude is less, but the wavelength is longer, and that's the redshift that we think, or the term make us thinking that there is expanding universe, but maybe that's just locally at our side. I leave it for other lectures. And then comes a very nice thing. So we move very fast in about the speed of light. Not quite so, but maybe 3/4 of that speed, or you have to go very fast to come over there. This is bigger, but this is shorter. This is lower, but it's longer. Because the power and frequency that we send out is so if we go faster in that direction, the light frequency goes to this. And when we travel behind us, when we travel, there is a redshift. And eventually, from all, that's a side note from me, from other lectures, eventually is all the frequency that will be sent out, even all these beautiful alpha, beta particles and frequencies, they are created somewhere in the deepest matter of our beautiful universe system. Eventually it will fade out, because when you start something with this stone ripple in the water, eventually it will end showing up some ripples, because then it's completely absorbed with a natural level of energy, the static level on the surface, but that surface level is also this fluctuation energy by this. So somehow, when all these light, even when we stop emitting, eventually it will go on and on and on and on, and divided by the radius squares 2, and it will be dissolved eventually. So all these light emitting bodies in our universe, all the suns, all the solar systems that create light, will, and every other wave length, no matter what it is, neuron, star, or everything what you can call it, everything eventually will fade out to the lowest possible frequency, because there will be no start point over here, and light will never end up endlessly with the same speed. There will be a distortion of this energy, and when it's distorted, it loses energy, and when energy is lost, the amplitude is losing. Just like a wave in water, when you got a high wave, it goes on and goes on, and eventually, in a straight channel, it will eventually also dissolve to nothing, but in comparison to the wave height, the water deepness, and the length of the channel, this wave will go on and on and on and on and on. But assuming you created exactly the same wave somewhere on a large lake, or in a sea, or in an ocean, it will finally dissolve in relation by this formula. The length and the amplitude is constant, and it dissolves by this formula, immer, always. Dutch, English and Dutch. This is always happening by that, but not from here, not from the starting point where it endlessly with a huge of a high amplitude, or here endlessly with a huge long wavelength, but it starts where the wave is started, somewhere on this point, on the same, actually it's over here, and then it's getting lower and lower. So this here means that when this is happening in our universe, and even when this is in a galaxy turning around with these beautiful spiral arms, you can see when you are here on Earth and you see something coming towards you, you see a redshift, and the other side of this spiral arm you will see a redshift. But eventually all the light that there is will finally, because all the light also emits light, because it bounces or it combines. So all these millions and trillions of stars emitting light also creates some combination with this energy flow, but eventually it fades out. Light fades out, because when it wasn't fading out, our universe would be totally white. We would never be able to watch outside because it was 100% light. It would always be full this, full that, and full that on every wavelength. So wavelengths, waves, they're always disperse as soon as they are free to radiate to the outside. But now comes the other part of this, and we are not there yet, because it's just beginning, because it's a bit strange. And when this light bulb, the same person, he's moving very fast, and now he got a supersonic ion motor, and it's traveling about the speed of light. And let we forget the special relativity, so that this rocket finally would be only a very flat thing with just one atom thickness, one atom thick. It would be squashed. Well, when that happens, all this particle science of physics will be torn apart. So this will dissolve. There will be not flying a plate to the sky with just a flat apparatus and with a platform. It will not be so, but it's just for the mind bubble over here. When you create an emitting light bulb with still the same wavelength, amplitude, that constant is plus minus times the length is constant. When you do this and you go with the speed of light, the only thing what you do is traveling from here to there. You only place some photon, one photon at a time, plus minus plus minus plus minus, with a wavelength unendlessly. For this, when it travels 300,000 meters in 1 second, 300,000 meters, and there we would have half, and we got one photon placed out of our light bulb. So our wavelength is just as long when we travel with the speed of light, momentum light. We place half, one light wave per second, and it doesn't have no more height than possibly is possible from our space, from where space is built of where in this this figure, in this math, in this expression, where this 300,000 meters per second come from. The energy field, the quantum field, or space without time, because time is something different in this place. There happening something without on a border, so you cannot emit more than is there. There is a dissolve. There is nothing to exchange with anymore. So when you travel with the speed of light, there is nothing. There's no light to be emitted behind. But if you look at the front side of this bulb in this direction, and you go as fast as the light can travel, if the light can travel, that light moves on through its own media, you will have this strange, just like a comet, you have these straight lines, and eventually, so it starts, let's say it, no, it's okay. So this light is placed also in front or in the back, a light emitting photon. So we place a photon or a wave. So eventually there will be some backwards, it's this, and the other side will going this way. And as long as it is, before it's eventually reaching the normal light speed. This, because this one he can travel, this one is actually just placed over here. And I try to do this. When I imagine that I am a light bulb, I emit a photon, a wave. And I wave it in 300,000 meters a second. So I place one photon, two photons, three photons in these 300,000 meters in 1 second. So I do it half, half, half behind me. I leave, when I shine on my light this way, I leave one photon, one photon, one photon behind me. But eventually, actually I should play towards red and red. But when I travel forward, when I travel this side, I cannot place any photon because it will build up here. So the only thing that can happen is that photons will go outside. So the first half photon goes this, goes that, goes that. This is what's happening here. So this line, you place photons as you place it, like you're placing peons from out of your car for the traffic sign equipment on the roads. So you place a peon, a peon, a peon. But in the front, they will bump away from you. So in front of this bulb, there will be no light emitted through here. And the side, English, yeah, that's quite difficult, isn't it? Yes, it is. Well, backward is this, in front it will be a spiral, and it will all some lines. With, just like a speedboat is going very fast, you see these lines away from behind. So you see a small movement sideways. But they also do this with speed of light by airplanes going very fast, 330 meters a second, speed of light in the air up there, 10,000 meters. But there's another thing we do. The only only thing we do is we don't send light, we don't send photons, we don't. We make interactions in our quantum field, in our space, in our ether. We create distortions, we place energy interactions with our ether, and it's the only thing we do. So when we do this, we actually place a small part that emits a small angular momentum over here. So we only place some parts, and the other one on the front, on the side, we place it over here, and place it over there, and we place it over there, and beneath we place it over there and over there, and more that we place in front of this rocket on this light bulb. We create something that's always bending away, so long as this according this line every time again. So we were here before and before that, so we only have some going outside that, but it's only photons placed here, there, 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 there. Light doesn't travel as a thing on its own. Light is a distortion of our local place where we make some interactions, where we make some energy interaction to that field on that place. It's just if you're when you're on water with a boat and you create something like this. So when you stand still, you have waves around your ship, and as soon as you move, they will bend in a wave, flip over a side. And only this force, this pressure times height and length creates this wave that's going outside, and it breaks off. So from a ship you have, in front of a ship, you have a wave that goes sideways. And the faster you go, it goes this. And the faster way it does. And over a long, when you go at speed as much as you can, there will be a straight line, nearly a straight line, because what you create in front of the ship is always the amplitude times it is constant. And only when the ship is, how do you call it, planing, then there's a small difference in this interaction. But in light, we also create a distortion locally in this universe, in this local place in the universe. No matter where we are on Earth, nearby the sun, nearby a black hole, somewhere in the most quiet place where there are no stars, no galaxies, when we emit light in that local energy field of our universe, where we all exist in, where matter came from, where matter and energy interact with each other by this lovely formula E. I hope this is on the camera. Yeah, I think so. This little equals sign. This little equal sign is actually all that's happening over there. And what we see here is some mind thinking about what we learned about how we have to see a light wave or a photon. So, and other relativity formulas with what's happening to the spacecraft when it speeds up to the speed of light, and other things. That's for physics, I know, but for me it's going time after time. The speed of light is proving that there's a medium, an energy field in our universe, and there are already a lot of numbers of common formulas, math formulas with this, and it's already, they already created this mathematical formulas what it is, but I see that they don't see that it's not something just, you don't buy it in the drugstore. You don't buy this in a drugstore. You don't buy anything from our universe in a drugstore. So, and all the behaviors we have been studied, been write about. We made some beautiful science, and it's really astonishing what we created in our last 50 or 100 or 150 years of science. And there are also many formulas that are combined together as they equals another entity of someone else's formula about science or so ever. But that's because they already know the outcome, they know, therefore they can combine formulas, have it, that it is just the way that it is, but it isn't. It's not complete. You cannot complete all the formulas because you can combine them because it's an other way of thinking about where this is coming from. And there are formulas, they are backwards countable, and they've created and computed back, and they said, yeah, you see, I got this 300,000 meters a second. No, that's because they both know they're coming from the same system where they made the mathematical equations. So the outcome is eventually always the outcome. Just like this experiment from Michelson and Morley, the outcome was complete. There was nothing. It proves just something like the ether. It proved the ether, but thinking otherwise, they said it was a mistake. It didn't bring us the answer that we wanted to have. But it was just another experiment, and it only proves what it was there. But that's for other lectures. I think this is really enough for this time, and maybe I will find out, or I will find some other parts of my former lectures to pick that out and make it expose something. I've done it in Dutch versions longer, more often, but I don't know if it's really necessary, because we only have to accept that nothing in the universe says you are 300,000 meters a second everywhere in the universe. That's the end of it. No, that's not the end of it, I can tell you. So, that's for today. Ladies and gentlemen, dear scientists, dear hobby scientists, dear interesting people, I hope that I told something you were able to follow what I say, my thoughts, and maybe you can watch other movies of me in Dutch or in English, and maybe in the future I will give you some more examples from this partial scientific source knowledge from my mind. That's it. I thank you for this evening, and hopefully you will share this with others, because there is a huge thing that no one will accept so easily. That this is not steady in the whole universe. So try me, I say. Try me and watch me. And when you wanna know something more about this, maybe I can give a lecture somewhere where you want it, or it's up to you. I have done my share for science for so long, and this is my conclusion together with some other lectures that I gave, and maybe someone understands it. I really hope, because I have no boundaries. I'm still living out of the box. I'm thinking out of the box. I am out of the box. Therefore, I'm free to think, and I think rational, just like Einstein did, and also Schrödinger about this wave-particle duality that I already combined in other lectures, just based on this principle that there is no spooky thing, there is nothing strange, there's no, we call it entanglement, you know, there is always a combination. The entanglement proves in this simple part, equals tells us that this is combined with that. So particles and waves are combined in these simple points in science. They tells us what it is. And if we don't know what it is, it's okay, you can't find it. But if you tell us, when you can accept and prove yourself that things that cannot be happening, then there is no unlogic. There is always logic that helps us further on in this life on knowledge and science. So, thank you for your time. I hope you enjoyed it. I hope you understand it. And please spread it out to others. Let others wonder if I'm telling you a good point. Maybe there can be maybe something more better, or maybe I can give some deeper information about other stuff that I know, that I learned, or from my other lectures, or that I combine with other lectures. But I think I really hit something many years ago, and I have spent it 20-30 years to how can I explain my thoughts, how can I tell others, how can I prove, how can I persuade others that there is no unlogic, that this exists, there is no unlogic for this, there is no unlogic for the expansion of the universe from nothing. That's my, some people think I'm a great thinker, I'm a huge brain, but I'm a simple thinker. I always choose the straight road to an answer. I don't bother, I don't have this bag full of obligations or rules or something. So I've learned all these years in the language of which others are talking about. I've learned to combine their language of science to what I think, to explain it, to explain others. But I can say this has to be something else. It must be something else. So that's why I've spent 20 years, and especially the last few years, that it can all bit by bit together, that I can finally make these lectures. I've wrote books, I make animations, I've made some great stuff, pictures and a lot of examples outside, inside, I did some experiments at home, all kinds of stuff. But eventually, to combine all this information in the last years, I realized that this is it. This is the first step beyond where we always have been since Einstein and Schrödinger, and especially Michelson and Morley. From that experiment it went wrong. Everything, in my opinion, went wrong from that moment because they have the wrong interpretation where they are made it experiments for. And eventually, I think I combined all these things: gravity, the speed of light, and dark matter, dark energy, the expansion of the universe, redshift. I created, in my opinion, all these lectures, all these theories, all these explanations of mine, all this talking, thinking. And that's why I love it. That's why I love it. And I hope others will understand me and follow my ideas. And we'll see. Maybe we'll get there. So, thank you for your time, and maybe till next time. And now I have to switch off the camera. Bye bye.